We're going to go back and work with complex numbers in this section. It's 3.8a because we're going to divide this into 2 days. But I want to kind of review what we talked about prior to this in regards to imaginary numbers. So remember what we have learned previous to today, that I equals the square root of -1 and I squared equals -1. We're going to need that information. And then I also wanted to review that a complex number consists of a real part and an imaginary part, and it is written in the form a plus bi, where a and bi are real numbers. So in this example, 3 is your real part and 4i is the imaginary part. And technically, all numbers are complex numbers. When we just talk about like the number 3, we just don't have an imaginary part. We have no imaginary part, so we don't have to actually write that. And on the off chance that we have something like this, we have 2i, that's still a complex number. Our real part just happens to be 0. So just keep those things in mind, that all numbers are complex, but we're going to be dealing with complex numbers that have that imaginary part in it that we have not ever worked with before. So keep in mind what I means, and then we'll talk about this as we go through. And I works like any other variable we have worked with before. So in adding or subtracting complex numbers, you combine your constants or your real parts and then combine your imaginary parts, just like when we have learned how to combine like terms. So we're going to consider an I similar to an X or a Y or any other variable. Just know that I is technically a constant. It does represent something. So when we add our complex numbers together, we look at our like terms. And we notice that this is a plus in the middle, so the signs in this second parentheses do not change. We are just adding everything together. In fact, we really don't even need the parentheses if you want to be technical. We can rewrite this without the parentheses, and then we can combine our like terms. A +4 and a +2 add together to make a +6. And then a -8i and a +3i add together to make a -5i. And that would be our simplified answer in a plus bi form. Okay, this second problem has a negative or a minus sign in between the two parentheses. That means we have to distribute that negative into that second parentheses. So once we distribute, we can write this problem without the parentheses. So I'm going to copy my first parentheses down, and I'm going to leave them off because I technically don't need them once I've distributed the negative. So that negative times the -3 technically makes that just become a +3. And then negative times the -7i right here, that just makes that become a +7i. Now I have no more parentheses. I've distributed my negative, and now I can combine my like parts. I can combine the real parts. 2 plus 3 is 5. And I can combine the imaginary parts. 12i plus 7i is 19i. Okay, that's about as simple as I can make it. And this will be the last step that we're going to do like later on when we're doing kind of putting all this together, the multiplying and the adding and subtracting. Adding and subtracting would always be your final step. Think of order of operations. We're going to multiply, then we would add our like terms, so to speak. So let's talk a little bit about multiplying. So when we multiply complex numbers, you use a distributive property, or we use FOIL, which is just another way of talking about distributing binomials. Again, when you multiply, unlike adding and subtracting, when you multiply, you can multiply any types of numbers together, any types of numbers whatsoever. It's just adding and subtracting have to have those like terms or like parts. So when we multiply, I'm just going to distribute through, and of course I'm going to multiply the constants, and then my variable will multiply it or tag along or however it looks. So -4 times 7 becomes -28, and then the I just tags along. And then as I distribute this next piece, I want to just point out, I'm going to go ahead and write a plus. I want to show you, I'm going to do -4i times -2i. I want to put that there so you can look at it. And you can actually see it there next to each other. So this front part is going to just stay the same, -28i. And when I multiply my two parentheses here of negative 4i and negative 2i, I'm going to multiply my like parts. So negative 4 times negative 2 becomes positive 8. And then I times I becomes I squared. And if you'll remember, I'm going to scroll just for a second. If you'll remember at the top of this video, top of these notes, what does I squared equal? We might want to keep that in mind, that I squared can then be simplified to that negative 1. So when we have that I squared, we can actually go ahead and simplify that. I went a little too far. So coming back to this, we had negative 28i, and we had positive 8i squared. Okay, because I times I was I squared. Now, knowing that I squared equals negative 1, I am going to substitute that in right here. And I'm going to have 8, positive 8, sorry, times negative 1. I was jumping ahead. And positive 8 times negative 1, well, then to simplify this even further, I'm going to put it in with I always want my real part plus my imaginary part. That's how I always want to write it. So my real part is negative 8. And then my imaginary part is minus 28i. So that would be my final answer. I should learn not to write so big because then I run out of space. Okay, let's move on to the next one. The next one is a binomial. So we're going to distribute the 3 through the parentheses. So let's go ahead and do that. 3 times 5 is 15. 3 times negative I is just negative 3i, just like if it were an x. And then I'm going to distribute the 2i through the second parentheses. 2i times 5 is positive 10i. And then 2i times negative 1i. I want you to look at it like this. 2i times negative 1i. Look at it like that. And 2 times negative 1 would be negative 2. And then I times I is I squared. So let's combine our like terms. We have like terms right here in the center. So we have 15. And then negative 3i plus 10i is positive 7i. And then we have negative 2, but then my I squared, remember my I squared equals negative 1. So I'm going to turn that into negative 1. 15 plus 7i, and then negative 2 times negative 1 becomes a positive 2. I can now add my like terms together, my like terms of 15 and 2, my two constants. 15 plus 2 is 17 plus 7i. And there is my final answer. And then the very last problem, I'm going to erase this so we have space. The very last problem is just a binomial squared. So if it would help you to write it out, you could write it out like this. Negative 3 plus 2i times negative 3 plus 2i, and now we can distribute. So let's do our negative 3 times negative 3, which is positive 9. Negative 3 times 2i is negative 6i. I'm trying to write smaller. Let's distribute my 2i through the second parenthesis. So 2i times negative 3 is negative 6i. And then 2i times 2i, well, 2 times 2 is positive 4. And I times I becomes I squared. So now let's combine our like terms here in the center and make sure we convert our I squared. So let's do that next step. So we have 9, and then negative 6i and negative 6i, we add those together, we get negative 12i. And then we get 4 times negative 1, because that I squared can then become a negative 1. We want to get rid of any variables that we can, or simplify any variables that we can. So I end up with 9 minus 12i, and then 4 times negative 1 is negative 4. So now I'm going to be able to combine my 9 and my negative 4. So 9 plus negative 4, or 9 minus 4, is 5 minus 12i. I know it seems like a lot of work, and it kind of is. It just takes some practice. Okay, that would be multiplying. So let's do a couple of things where we put it all together. So here's an example of where we can put it all together. Whew, this is a lot of problem solving. So we have some multiplication going on here. We have some addition and subtraction going on here. So kind of combining the lessons that we did above, the first thing I'm going to want to do is distribute this negative through and go ahead and do the distribution here with all this stuff right there. So I'm going to rewrite without my parentheses, 2 plus 8i. I'm going to distribute that negative. So the negative times the positive 4 becomes negative 4. And then my negative distributed to the negative 3i becomes positive 3i. So now let's go ahead and distribute my 1. And everything's going to be just addition and subtraction here. Once we are done with all of our multiplication, then we can just combine our like terms. So 1 times negative 6 is negative 6. 1 times positive 2i is just positive 2i. I times negative 6, well, that would become negative 6i. And then I times 2i, well, that just becomes a positive 2. And then I times I gives us that I squared. So now we can combine all of our real parts. So 2, negative 4, negative 6, and that's all of our real parts at this point. And then we will combine all of our imaginary parts. I'm going to make sure I kind of identify those here so you can see all the real part or imaginary parts. And then my very last step, I will convert that I squared. I don't want to forget to do that part as well. So 2 plus negative 4 is negative 2. Okay, right here, negative 2. And then negative 2 and negative 6 gives me a negative 8. Okay, so I've added all of those together. Does that make sense? 2 minus 4 is negative 2 and then negative 6. All right, next one. 8i plus 3i is 11i. And then plus the 2i gives me 13i. And then minus 6i. 13 minus 6i is positive 7i. Plus my 2 times negative 1, because this I squared changes to a negative 1. Okay, so I have negative 8 plus 7i. 2 times negative 1 is negative 2. Combine my like terms again. Negative 8 plus negative 2 is negative 10 plus 7i. There's my complex number. All right, now what you notice over here, we have some radicals with some negatives underneath. So just a refresher of where that I comes from, let's first simplify our radical parts so that we can get rid of those radical parts. We do have 2 perfect squares, but we have that negative underneath. So inside my parentheses, I have negative 4, the square root of negative 4. Well, I can break that into, just to remind you, negative 1 times 4, which is the square root of negative 1 times the square root of 4. So I can take the square root of 4 and I get 2, and the square root of negative 1, reminder, is I. Okay, and then my square root of negative 9, well, the square root of 9 is 3, and the square root of that negative is I. So anytime you see a negative under that radical, it's going to turn into an I outside the radical. So let's distribute. So negative 5 minus 10i plus 3i. I just distributed through. Combine my like terms. Well, I don't have anything to go with my negative 5, but I do have some imaginary parts. Negative 10 plus 3 is negative 7i. There is my simplified answer.